Today I'm going to forget about the usual symbols we use for math. 1, 2, 3, 4. Those aren't numbers, they're just symbols, and often they make it harder to see the neat patterns that numbers make. The ancient Greeks, like many cultures before them, loved to play with numbers and look for patterns. They didn't always use symbols to represent numbers either. They used whatever they had around. Archimedes was famous for drawing circles and other shapes in the sand to discover their properties. Ancient Greek mathematicians often used rocks to represent numbers. What's more ordinary than a rock? So we're going to use rocks today. Let's start with 1. There, that looks nice. Nothing really special is going on yet. I've decided I'm going to make squares. I'll add 3 rocks to make a square of 4 rocks total. Cool, that's more of a pattern. I have 2 rows of rocks, or a 2 by 2 square. 2 times 2 is 4. That's why 4 is a square number. It can literally be arranged in the shape of a square. Okay, let's make it bigger. I'm adding 5 more rocks to make a 3 by 3 square, a square of 9 rocks total. That's a nice square. It's very neat, like a tic-tac-toe board. I guess 9 is also a square number because here we have 9 rocks in the shape of a square. Okay, let's make it bigger. I'm adding 7 more rocks in the shape of an L here. Alright, now I have a 4 by 4 square. 16 rocks total. I'm starting to notice a pattern because every time I want to make my square's side bigger by 1, I have to add a greater number of rocks. I started out with 1 rock, and when I wanted a 2 by 2 square, I had to add 3 rocks. The next time I had to add 5, and this time I had to add 7. Each time I have to add the next odd number, 1 plus 3 plus 5 plus 7. I'm guessing that to make a 5 by 5 square I need to add 9 rocks, and to make a 6 by 6 square I need to add 11. The coolest thing about this is that when I start adding up all the odd numbers, I keep getting square numbers. 1, 4, 9, 16. I can see that if I add 9 to 16, I'll get 25, and that's 5 times 5. And then if I add 11 to 25, I'll get 36. 6 times 6. Neat, huh? Okay, let's look at another shape we can make with rocks. I want to add up all the numbers, not just the odd ones. I can just start making piles, but I don't really see much of a pattern. Why don't I try arranging them like this? I can start making a triangle. Each time I add a row, I just make the triangle bigger. We had square numbers last time, now we're making triangular numbers. But as the numbers get bigger and bigger, I'm having trouble keeping track of how many rocks I have. I can keep adding numbers, 1 plus 2 plus 3 plus 4 plus 5 equals 15, but that takes too long if I just wanted to know what the 10th triangular number was without knowing what the 9th one was first. I wouldn't want to add up all the numbers up to 10. Now I've got 6 rows of rocks, and I'd really rather not count them all, but I don't see a good way of figuring out how many rocks I have without adding or counting all the rows. I'm going to try arranging the rocks a different way to see if I can find another pattern. Okay, that looks different. But I still have 1 rock in the first row, 2 in the second row, 3 in the third, and so on. And now I can see a way to figure out the number of rocks. I'm going to add the same triangle upside down to make this into a rectangle. We can figure out how many rocks are in a rectangle the same way we figured out how many were in our squares, by counting how many rows we have and how many rocks are in each row, and then multiplying those numbers together. I want my second triangle to look different, so I'm going to use these paper fasteners instead of rocks. I'll make the second triangle the same way I made the first, except it will be upside down. That way I'll be sure I'm using the same number of objects and the triangles will be the same. Now, the rectangle is complete. I just have to count the number of rows and the number of items in each row. I figured out that I have 6 rows and 7 rocks, or fasteners, in each row. 6 times 7 is 42. Now I have to cut that number in half to figure out how many rocks there are. 42 divided by 2 is 21. This should work for any number. If I want to know how many rocks there are in the 10th triangular number, I know I'll have 10 rows and 11 items in each row in my rectangle. 10 times 11 is 110. We just divide 110 by 2 to get 55, and that's the 10th triangular number.